two radar stations. Both detect a UFO between them. The angle of elevation measured by the first station is 35 degrees. The angle of elevation measured by the second station is 15 degrees. If the UFO is 15 miles above ground, how far apart are the radar stations? Round your answer to the nearest tenth of a mile. So on this particular problem, what might be helpful for you is if you highlight it or color it a little bit. And the thing is, we're going to be finding this triangle here. And then we're going to do this triangle here. And then if we go back and look at the entire question here, what it says is, it says, how far apart are the radar stations? Well, here's one radar station, and here's the other radar station, so eventually we're going to be finding that distance. But we've got the triangles broken up now into two, and the nice part is that they share some common parts. But if we start with the yellow triangle, since we did that one first, here is the hypotenuse. There's our right angle. Across from 35 is the opposite, which in fact is going to happen to be an opposite in the green triangle as well. And then this side is the adjacent side. And in our triangle, the opposite side is labeled H. But if we go back and look at the problem, what it says is, it really says, the UFO is 15 miles above ground. So this length right here is 15 miles. Trying to write the 15 there. Try one more time. Not much better. But what we know here is we know the opposite length is 15. We want to find the adjacent length because, again, we're trying to find the distance between those two red dots. So when we set this up, again, we know opposite. We want to find the adjacent. I'll label it x. And that means that we're going to do a tangent function because we know opposite and we want to find adjacent. What function relates those two? Tangent of 35 equals 15 divided by x. Remember, in order to solve this, what we're going to do is we're going to switch places. The tangent 35 and the x are going to switch places. So this is going to become x equals 15 divided by tangent of 35. And that's what we're going to go ahead and type into decimals. 15 divided by tangent of 35. And we get 21.4. We'll go back and look at the units here. But the problem says round your answer to the nearest tenth of a mile, so we're going to stick with our 21.4. And down here, let's label the triangle with that. So let's switch over to the green triangle. Here in the green triangle is going to be roughly the same. I wish that I had a little bit more space beside my other function here. But as we go ahead and label it, like I said before, the 15 is still the opposite. But I should have labeled my hypotenuse first, which means that down here is the adjacent. And once again, I'm going to call this y. And when we set it up, we know the opposite. We want to find the adjacent. And the function that relates opposite and adjacent is still tangent. So this one's tangent of 15 equals 15 divided by y. And in order to solve for y, we're going to switch places with the tangent of 15 and y. So it's going to become y equals 15 divided by the tangent of 15. And we'll go back over to decimals and type that in. So it's going to be 15 divided by tangent of 15. And we get that value here of 55.98, which when we round it to the nearest tenth, is really going to become 56. The 8 is going to cause our 9 to go up to 0, which is going to cause our 5 to go up to 6. So 55.998 becomes 56. So we can put that back in our problem here. So y equals 56. And here's that length in our triangle. And again, to finish, what we want to know is how far apart are our two radar stations. So we're going to take the 56, and we're going to add it to the 21.4, and we end up with 77.4. Looking at the units here, miles.